All right, to continue where we left off. After I've had a late breakfast. So we had our oak block on an oak inclined plane, inclined at 50 degrees from the horizontal. As we said, these are coefficients of friction, coefficient static, coefficient kinetic. We're saying the mass of the oak block is 10 kilograms. We've already derived our formulas. We've already seen in this situation that the force of gravity parallel to the incline would overcome the maximum force of static friction, so it would move. And then when we see the force of kinetic friction, it's 30 newtons the opposite direction. So using the second law, Newton's second law, F equals ma, we get the net force, 75 minus 30, 45. So there's a force of 45 newtons down the inclined plane, and that's approximately 11 pounds, 12 down the incline. So we shall continue with this. As we said, F equals ma, second law, get the net force, divided by the mass, 45 over 10 is 4.5, an acceleration of 4.5 down the inclined plane. So we have that established, and then we will go with that. So we go through this and see what the net force is along the inclined plane. And of course here, only gravity is pulling it down, and the normal is pulling up. But if we had a string pulling up, then the weight would be reduced. So we would say like gravity's pulling down, and if we had a string pulling up a little bit, then the string and the board would be balancing gravity. So this is not going up or down. Perpendicular 63, let's say we're pulling with 5, then a 63 Newton force of gravity, 5 opposite it, then we'd only have 58 on the board. 58 plus 5 would balance the 63. There's things like that we can consider, but let's look at going down the inclined plane. Okay, so the 63 minus 5 to get 58 for this, we subtract to get kind of like in this situation. So we're doing that already. We have 4.5 meters per second squared. All right, so let's say we've done this analysis, and then we can go acceleration, 4.5 meters per second squared. Then let's say that the object starts out at 7 meters. How about just 7.1 meters up the board. Let's say from the bottom to here, 7.1 meters. To this point here. Make sure it's all clear. To where it comes down. From here to where it's going to come down to the ground, 7.1 meters. So, what's the velocity when it gets to the bottom? We just use the information we have now and do our equations of motion. So, we know we have A is 4.5 meters per second squared. D, or S, D for most people, S in IV speak, is 7.1. It starts at rest. Initial velocity is 0. What's our final velocity? Write down your given, please, then match up the letters. We have these 4 things. We look at our equations of motion. We see which equation has these 4 things in it. Then it's obvious that we use v squared equals u squared plus 2as, or 2ad. Plug in our numbers. V squared is 0 squared plus 2 times 4.5 times 7.1. Then clear second. Well, I did it first. So 9 times 7.1, 63.9. So v squared is 63.9, pretty much close to 64. So v is 8 meters per second. Cool. I wish I could say I thought of that ahead of time so it would come out to be 8. And I picked this and this and this on purpose, but I didn't. It's just accidental coolness. 8 meters per second. Okay. Or we could do, given this stuff, how much time is it going to take to go down? So let's say we got this. We'll pretend this is a completely different problem. We did that. So that's the velocity at the bottom. Now let's say we want to figure out the time. So A, S, U, T. We got our letters. We look at our equations of motion. We see which equation has these 4 letters in it. And then clearly it's going to be S for the IB stuff. I'll do it for a non-IB in a second. S equals UT plus 1/2 AT squared. And in non-IB speak, this would be like D equals initial velocity times time plus 1/2 AT squared. So I guess I won't do it in a second, but you know, we got different letters, symbols, the same stuff. Then we got 7.1 is 0 times t plus 1/2 4.5 t squared. So then 7.1 is 1/2 4.5 t squared. T squared would be 14.2 divided by 4.5, 3.2, and then square root, second square root. So about 1.78 t, 1.78 seconds. Okay, so there's another one. We could do something like this. We've got the acceleration. What's the velocity at the end? How long does it take to get down? Stuff like that. Or let's say if we do, okay, the final velocity was 8. Maybe we could do something like this. Here's one we have not seen. Some of you, but not all of you. We could do how far does it travel as the speed goes from 1.5 meters per second to 6.47 meters per second. So initial, what did I say? I forgot, 1.5 meters per second. Final, I don't know, let's change it. Let's say 5.47. So let's say we want to figure this out. How far does it travel as it goes from here to here? And again, letters, equation. Letters, equation. Which is it? B squared equals U squared plus 2AS. Or in non-IB speak, V final squared is V initial squared plus 2AD. And then we solve, and we get 5.47 squared equals 1.5 squared plus 2 times 4.5 times S then we work it out. So 5.47 squared minus 1.5 squared equals 27.7 approximately equals 9S, because 2 times 4.5 is 9. And divided by 9, 3, yes, 3.08 meters. So, kind of sort of around half. So to go from this speed to this speed, it travels 3 meters. So there's things we can do with this. Screensaver came on. Okay, so we can start with the acceleration that we figured out from this stuff, and then do different things with it depending on what we want to know, what you're asked, and all that in a certain situation. So cool. And there's other things that could be done, but there are some examples of getting the inclined plane situation, then applying EOM, equations of motion. Enjoy.